This is the Precalculus Fall 2016 ACP preview. This is problem 7. It has to do with a discontinuity problem. In this case, we have Polly was given a rational function, and we have f(x) equals x plus 3 over x squared plus x minus 6 plus 4. What discontinuities did Polly discover upon her investigation of this function? I want to first explore a non-calculator type of solution, and one thing we can notice is we look at our answer choices. We have we're looking at types of discontinuities: removable discontinuities or infinite discontinuities. An infinite discontinuity is a vertical asymptote. Also, an infinite discontinuity is a non-removable discontinuity. A removable discontinuity will be a whole or a point discontinuity as well. And we realize that in these first 3 answers, we have both a removable and an infinite discontinuity. So we have different types of discontinuities. What we're going to do is rewrite this rational function. We're going to do that by factoring the denominator here, which is x squared plus x minus 6. Well, in order for one of these things to become a removable discontinuity, one of the factors of this x squared plus x minus 6 is going to have to be x plus 3. And if one of the factors is x plus 3, what times x plus 3 equals x squared plus x minus 6? Well, we're going to have x minus 2. And if we multiply these back together, we'll see we have 3 times x is 3x, and negative 2 times x is negative 2x. We're going to get positive x. So I'm going to add this plus 4 over here. And since these x plus 3 and x plus 3 cancel each other, we have a discontinuity at x plus 3 equals 0. So x equals negative 3 is one of our discontinuities, and also we have x minus 2 is equal to, well, I'm going to put is not equal to 0, and the not equal meaning that is a discontinuity. Well, x cannot equal 2. And so our discontinuity is going to be at x equals negative 3 and at x equals 2. Well, over here, that's going to disqualify answer choice C for sure, because we have different numbers. And then for D, well, D only has an infinite discontinuity. That's not going to work. And so this one here, since we've canceled, this one right here, this is our removable discontinuity, or whole. And so where do we have removable discontinuity? At x equals negative 3, well, that's answer choice A. So that's an analytical way of working it out. As far as a graphing calculator, if we go to our calculator and put this in here, if we go to tab and enter this function here, rational function, and in the division bar we have x plus 3 in the numerator, and x squared plus x minus 6, and over here to the right we put plus 4, and we graph this. We see a vertical asymptote, or infinite discontinuity, at x equals 2. We do not see the discontinuity at x equals negative 3 because it's removable, and we can verify that if we go to Control T to get our table view. We can see at x equals negative 3 we have our output values undefined. So that's since the discontinuity is there, we cannot see it. This is an example of a removable discontinuity, a point discontinuity, or a whole. So that verifies this answer choice A. I want you to take a look at your other problems 7A and 7B, which are supplementary problems that test the same concept to further your extend your understanding and be a further check. Good luck, and thanks for viewing.